Let's take a look at a special type of triangle, a right triangle. A right triangle has one 90-degree angle. And there's a special fact about right triangles that have to do with its three sides. But first we need to make sure we understand how to talk about the sides. The legs are the two that are attached to the right angle. The hypotenuse is the other one. It happens to also be the longest side. No matter what, it'll always be the longest. On a right triangle, the fact is with the Pythagorean Theorem. That is, a squared plus b squared equals c squared. So you take whatever the measure of a is and you square it times itself, add it to the square of b, and the sum of those two things will always be equal to the square of the third side, no matter what, for every triangle that ever exists. Again, it's called the Pythagorean Theorem. Try practicing saying that. The Pythagorean theorem of a squared plus b squared equals c squared is going to be very useful in finding the missing length of one of the sides of a right triangle. It has to be a right triangle, of course. Okay, so what we do is we figure out which two are the legs. They would be the two attached to the right angle. They go in for A and B. It doesn't really matter which one you put for A and which one you put for B, but people usually pick the smallest for A. Next, you square both of those. 200 squared is 400 and 21 squared is 441. Those two, the sum, is 841. Now that's equal to c squared. But what we really need is just c by itself. So if we square root, the opposite of squaring, if we square root both sides, then we will find the square root of 849 is 29. And that would be the length then of this side of the triangle. So to review, we used the Pythagorean theorem. We substituted in the legs of the triangle for A and B. We didn't know C, so the hypotenuse, by the way, is called the hypotenuse. And that was C, and we left it as C, C to the second. Let me show you how to use our calculator to find the square root of a number. So let's try it out for 448. First, you select the second button, which is right here, and then the square root button down here. It's the opposite of the x to the second power. You can see the little blue radical sign above that button. Type in your number, 448, hit enter or equals, and you should get this as your result. Okay, let's find the length of the hypotenuse of this right triangle. Again, the legs are the two, the A and B, attached to the right angle, where the C is going to be your hypotenuse, the longest side of the triangle. Okay, pause the video and try this one. So the first step is to substitute in the A, B, and C. The legs are your A and B, so we would have 3 squared plus 4 squared, and that's going to equal our hypotenuse, which we don't know, so we'll leave it as c squared. 3 squared is 9, 4 squared is 16. We add those together to get 25, but that's still equal to c squared, where really what we want is just c. So let's square root both of them. The square root of 25 is 5, and the square root of c squared would just be c. So there is the length of the hypotenuse of this triangle. So the Pythagorean theorem is actually very useful in very many real-life situations. Here we have a ladder that's leaning up against a building. It reaches the top of the building, so it reaches up 10 feet, and its base is 3 feet from the building. So we're going to figure out how long the ladder is in feet, and round to the nearest tenth. So first make a drawing of what it's talking about. Here we have the house. We're showing it's 10 feet up the side of the house and 3 feet out. And then we use the Pythagorean theorem. Go ahead and pause this one and solve for the missing hypotenuse. Okay, so check how you did. Substitute in the 3 and the 10 for the a and the b, and solve. Remember to use your calculator to square root the 109 and round it to the nearest tenth. So the length of our ladder is about 10 4/10 feet. Okay, pause your video and find the length here of how far the base of the ladder is from the building. You're going to find that this one's a little different. We're not missing the hypotenuse, or the C, we're missing one of the legs. So I chose to write down B is missing. So you're substituting in the 14 in place of A and the 18 in place of C. Then square 14 to get 196. Square the 18 to get 324. And use what you know about solving equations to undo the positive 196. We're going to need to subtract. So b squared equals 128. But we don't want b squared, we want just b by itself. So square root the 128, round to the 10th, and it's 11 3/10 feet. Here we have the diagonal path through a rectangular garden is 40 feet. The length of the garden is 30 feet long. So how many feet wide is the garden? So I'm going to just figure out where my triangle is at. I could pick either the top half or the bottom half and know that I'm missing one of the legs. So I'll make that A. So in this one, we're not missing a hypotenuse. Once again, we're missing a leg. Go ahead and pause this video and try this problem. So you substitute in the 30 in place of the B, square it to get 900. 40 goes in for the C, that's the hypotenuse. Square it to get 1600. And we have a squared plus 900. We need to use what we know about solving equations to undo this, and we're going to subtract 900 from both sides. So a squared equals 700. Now remember, that's not a, so we need to go ahead and find the square root of 700, which is 26, rounded to the 10th, 26.5 feet. So that's how wide the garden is. So if you're only given lengths and you don't know which one's A, B, or C, you can figure it out. You know the longest one has to be the hypotenuse. And then it doesn't really matter which one you pick for A and B, but again, people usually pick the short one to be A and the next one to be B. So in this one, we are told the 3 side lengths. We just don't know if it's a right triangle. Well, if it is a right triangle, then it will follow the rule of the Pythagorean Theorem. So let's just substitute in the numbers. So 78 has to go in for the hypotenuse because it's the longest, and then 48 and 60 for the legs. And then you just simply solve both sides of the equal sign to see if they come out the same. They don't. So this one is not a right triangle. Okay, pause the video and you try this one to find out if the triangle is a right triangle. Remember, to determine which one's the hypotenuse or the C, it would have to be the longest side length. So substitute them in, square each number, find the sum of the legs being squared together. And since both sides of the equal sign do not match, it's actually not equal. Notice the not equal sign. Nope, the triangle's not a right triangle. Now in this one, it all comes out equal on both sides. So this would be an example of it is a right triangle. Pause the video and do this last check your progress problem. Okay, how did you do? Substitute them in, solve both sides of the equal sign. You'll find that they are actually equal. So yep, it is a right triangle.